Hi guys, hello everyone. Hi, good morning. So I'm really happy to be here at NASA iTech, and I want to thank Mark for breaking the ice. So, I'm Luis, I'm the founder of HTRAP1, and the reason we're here at NASA iTech is twofold, right? First, we want to look at problems that we have on Earth and find solutions. The other reason is that we're looking to solve some critical challenges for space travel to get to Mars. So I'm going to take you on a bit of a roller coaster ride. And let's start by going to the sky. And let's just imagine for a second a future that's based on hydrogen. So what would that be like? We would have abundant energy, right? We'd have abundant water resource. We'd have zero greenhouse gas emissions. But unfortunately, we're not there yet. So let's go back to reality.
Federal accident investigators are headed to the site of a massive natural gas explosion in Junction City, Kentucky. One person was killed and at least 5 others hurt. And as Meg Oliver tells us, it was seen and heard for miles.
It's getting bigger.
The gas explosion sent a thunderous fireball 300 feet in the air.
It felt like you're standing next to a blowtorch.
53-year-old Jody Coulter lived less than 200 yards from the blast. She suffered burns on both arms as she ran from her burning house.
Okay, this happened 2 months ago in Danville, Kentucky. The explosion was 300 feet wide and about 14 feet deep. Unfortunately, one person was killed and a handful of people were injured. About $500,000 of natural gas was consumed before it was extinguished 3 hours later by firefighters. Now, we won't know for about a year to a year and a half what was the cause of this, but most experts are already pointing to corrosion as a major cause. So it's a real issue. It's actually, in the oil and gas industry, it's a $1.37 billion a year issue. And we also have some other issues. There are 8,000 power plants that are run by natural gas in the US alone. And there's about 1,000 failures a year. So, which means if you guys live near a natural gas power plant, there's a 1 in 8 chance that you will experience a failure this year. This not only causes a loss in revenue to stakeholders, it's going to cause a loss of revenue to the businesses that are affected. It's going to affect families if it's in the winter and they need to stay warm. So this is something that is really an issue in the US, and I want to ask you a question. Like, what if we could double the amount of energy going through our existing infrastructure with minor modifications? What would that mean? So our solution comes from nature. Everyone's familiar with yeast, right? If you've ever drank a beer or ate some bread, you're already familiar with this. My sister says it's a molecular beast. So our solution needs only sucrose. It's biodegradable, it's inexpensive. And it can be used in natural gas and hydrogen storage tanks, in fuel cells, in agriculture. What we are proposing is to produce a coating, an internal coating that can trap hydrogen, which would increase the flow through the pipeline while protecting the pipeline from embrittlement and the corrosive effects of natural gas and hydrogen. Again, it's an internal pipeline, an internal coating for pipelines. So I'm going to go back a bit and talk how this started, a little bit of our origin story, if you will. 10 years ago, Dr. Smith from New Mexico State University was working on waste-to-energy project. Him and Dr. David Johnson, they're literally turning manure into energy. And through that microbial community, they discovered a very novel, actually a few, but the one that we're interested in is a very novel yeast that can produce a bioelastomer. They got some grant money through this discovery. A few years later, there were patents awarded, so we have 2 patents on this technology. Just this year, we founded the company, and we have exclusive license to these patents. We've been working very closely with the university, with New Mexico State University and Arrowhead Center. I'm the founder, and I have a background in biochemistry with entrepreneurial experience. Alex Gorsuch is a multidisciplinary engineer. He's also a serial entrepreneur, and he's also involved in an SBIR project, which is useful because this is one route we are looking to take. Dr. Jeffrey Smith is the inventor, as well as Dr. David Johnson. And Dr. Smith has over 40 publications. He serves on NIH, USDA, and NASA grant review panels. He's currently on sabbatical in Paris, or he'd be here today. So we're going to talk a little bit about the technology, what makes it unique. So this is a residual gas analysis. So what we did is we painted the elastomer onto nickel-plated foil, and then we ran deuterium, which is basically hydrogen, through it, and we tested the permeation. And through this graph, you can see that it does indeed block the permeation of hydrogen through that nickel plate. Another test we ran was a TGA test to test its heat resistance. We've proven that it's heat resistant up to 200 degrees C. This is just the polymer alone without any addition from other materials to develop a coating. Okay, so why is this useful to NASA? Right, let's go back to space, if you will. This is useful because NASA uses hydrogen in space travel, fuel cells, also in fusion. It's literally lightning in a bottle, right? However, oops, I think that's the wrong way. However, hydrogen, because it's a high-density energy carrier, it's notoriously dangerous and difficult to handle. Until now, right? We have our H2 elastomer. We can make it safer and easier to handle, both for spacebound applications as well as earthbound applications. I'm going to talk a little bit about the current infrastructure. Currently, there's about 2.5 million miles of natural gas pipeline in the US. It's enough to go to the moon and back about 5 times. There are only 1,600 miles of hydrogen pipeline, and they're mostly near point-of-use stations. So it's not well integrated into the entire US system. By using our product, you'd be able to produce an internal coating where we could introduce up to 50% of hydrogen into the natural gas pipeline, which means we'd be able to provide natural gas for the United States. We'd be able to provide hydrogen to the United States. Again, this is a transition because we are looking to go towards a hydrogen economy. By introducing our coating, we'd be able to combat corrosion, improve the flow rate, which would increase productivity, and also make it able to accept hydrogen. A little bit on the financial data. We analyzed what it would cost to coat 1 mile of pipe. It's going to be, from our initial estimates, about $20,000 to coat a mile of pipe. However, by introducing hydrogen, you'd be able to get 2 times the overall energy. You'd be able to save about $27,000 per mile just on the reduced need for fuel by the compressor stations, because hydrogen is a lot lighter than natural gas. Based on our sub-licensing model, we'd be able to charge a royalty scheme of about $2,000 per mile. Again, these are initial estimates. We can talk more about this at impact tables if you guys want to go into it. Now, how do we match up against the current solutions? So right now, replacement is extremely expensive. You need labor costs. You need to get new pipelines out there. Usually, you got to excavate. Competing coatings, they're about the same cost. However, they do not have the benefit of being able to trap hydrogen. Next one. Okay, so where are we today in our development? We're at TRL3, so we have 2 patents. We've formed the company, this year we are trying to finish our initial scale-up and optimization. Next year we want to do product development. We're looking to form partnerships, so that way we can do such things as cryogenic testing, which would be important if we want to use this in space, right? We also want to test the usual lifespan of our product, and we want to do initial coating development. By 2021, we're looking to actually put pipes in the ground, do our proof of concept, do quality assurance to make sure we can adhere to ASME standards. And by 2022, we are looking for sub-license or multiple sub-licenses of our technology. So again, why am I here at NASA iTech? Well, we do need your guys' help. And one thing that we do need is we are lacking in pipeline industry expertise. We do need people who know pipelines, who know this business, who can help us develop this technology. We also have been working closely with NMSU. We have done work through Sandia as well, and we are looking to do work with Los Alamos. But we would like access to more test facilities, to more labs, such as NASA's cryogenic testing facility. We are looking for strategic partnerships with different organizations to develop our technology profile. And of course, everyone needs funding, right? Eventually, we will be looking to sub-licensing. Before that, we need to work on collaboration. So this is not only useful for an internal coating, guys. This is also useful, as I mentioned, for an H2 storage tank. We can use it to construct seals for centrifugal hydrogen compressors. This is a problem right now. Pipeline maintenance and repair. Also as seals or gaskets. It also can be used in the bioplastics industry. So I'm going to leave you guys with 3 things, right? If you just take these 3 things today, I would say, first of all, it's an angstrom level polymer. It's very small. It can trap hydrogen. This is what makes it unique. The second thing is it's a bio-based solution. It's made from yeast. And the third thing, it's cost effective. So H2 elastomer really is value you can capture. So I'll take any questions. Thank you. And Alex is going to come up and he's going to help me.
And who's Alex?
Alex is our serial entrepreneur and a business development advisor. Thank you.
So have you done any permeability testing with natural gas on this polymer?
No, we have not actually. And that is something that we're looking to do in the future. We do hypothesize that because it can trap hydrogen and hydrogen is so small, it would also be able to trap larger molecules such as natural gas.
How thick and heavy would this be to be effective for hydrogen entrapment?
How heavy would the polymer, how, do you mean the...
Yeah, how thick is it and how heavy is it?
So this, the thickness, because our tests are on the nickel-plated foil, we just put like 2 layers. The coating has yet to be developed, so we haven't determined the thickness. We would like to keep it as thin as possible. As you know, like FEC coatings need to be quite thin, right?
Along that line, how would you expect this to be employed? How do you expect to actually coat your material inside the pipes?
Okay, are you talking about new pipeline construction or like retrofitting existing pipeline or new pipeline
Either.
construction?
How do you plan on getting it in the inside?
Inside the pipe? So we can use filming pigs. So by using if we're going to do it in the field, we could use filming pigs to put the coating on actually when it's already in the ground.
And are you using any other materials to make your elastomer adhere to the pipeline?
Yeah, we will be developing the coating, and that's something that we're looking to do with strategic partnerships. We can talk more about that at the impact table, if you guys want. Yeah.
Have you done tests with fluids flowing through? I mean, how well does it withstand the speed and pressure of the fluids?
Like hydrostatic testing? Yeah, so we're still looking to do those tests in the future. This is part of our development plan for 2021. There's a slew of tests that we want to do.
Have you developed the biopolymer separately such that that could be coated on, or you're putting in live yeast sugar solution into these pipes?
Oh no, we're putting we're using the yeast to grow the polymer.
Right, and then you apply the polymer.
Then we will separate it from the yeast. But the polymer is an exopolysaccharide, so it can actually be extruded from the yeast. So nature does like 80% of the work to remove the yeast from the polymer. Then we will continue separating it, and then apply that to a coating.
Okay, so it's polymer applied, not the yeast.
Yeah, the yeast will be tossed out. Yeah.
Yeah, okay.
Luis, you used the term hydrogen capture versus permeability. Can you discuss a little bit what you mean by capture versus permeability, or in my nomenclature, permeability?
Okay. Let's see. I'm not sure if I know exactly what you mean. Do you mean by instead of like capturing the hydrogen, or?
Right. So, when I think about a pipeline coating, you're typically coating a pipeline to prevent permeation of your contents inside the pipeline to the outside, whether it's a gas or a liquid. You're not actually capturing the molecule. You're just making sure that the molecule can't pass through.
Exactly, yeah.
And you say hydrogen capture, that's a little different nomenclature in my mind.
Okay, I see what you mean. Let me go back. Sorry, you mean this slide? Sorry.
Not so much in one of the slides.
The point is it's an adsorbent, so it can capture hydrogen on the surface, but not it will also eventually it'll just block it.
Okay.
Yeah.
You've predicated your business model based on a hydrogen economy happening, which is a big that's a big guess right now.
Exactly.
Where would you say your low-hanging fruit was revenue-wise at this point?
Can I get that one?
Is this already open? Sorry. Anyway, I'll just talk a little about it. In terms of beachhead market and specific pipeline, we are looking at Texas. That is 1/6 the pipelines in the U.S., as well as 20 hydrogen plants. In terms of low-hanging fruit, we're really interested in developing the coating more and doing a lot of the tests that we talked about. Thank you. I'm too stupid to figure out microphones, I guess. Is that working? Yes? Okay.
Cool.
Excellent. So we are really interested in developing the coating and doing a lot of those tests that we talked about. Chiefly, we're really interested in the NASA applications. And I know from talking with the good folks here at iTech that the biggest test that we need to run to determine suitability for that are those cryogenic tests. While we are rated up to 200 Fahrenheit, as I understand it, that really don't mean much within the context of space. So.
Can I ask, have your patents published yet?
Yes, our patent's already published. One patent was awarded in 2016, and the other patent was awarded in 2018.
So they've actually issued as opposed to published?
They've been issued.
Different?
Yeah, they've been issued.
Okay.
Robin, can you put me back on? Sorry. This thing has a mind of its own. So. Any more questions?
This sounds like it's more of a sealant or a protectant. What is your other competition out there right now as far as the types of compounds that are used to seal the insides of pipelines?
Yeah, there's two major I guess materials that are used: PE, polyethylene, and fiber reinforced polymer. These are the two major competing. If you saw that slide with competing coatings, that's the two coatings we're talking about. I would like to add, though, that those coatings cannot trap hydrogen. They cannot block hydrogen.
Have you been able to do any tests as far as the hydrogen storage or capture or whatever on a per volume basis?
No, we haven't, and that's one reason we're here today, is because we're looking to partner with folks such as yourself to be able to pursue those tests.
Thanks very much, Luis.
Thank you, Tom.